What's up, everybody? Welcome to Air Science. So those two videos you just watched, hopefully they weren't too painful. Hopefully you thought they were cool. And just meant to reinforce this idea that, all right, it's really this, where we did the stars. We're going to do a little bit with deposition today, but it's not going to be a whole lot that's new because it's really just the opposite of erosion. If water speeds up, it picks up particles, and that's erosion. But when it slows down, it drops them off. And that one video did a pretty good animation of showing that. So yeah, we're focusing a little bit more on the drop off part today, but we're not going to beat it to death. It's not going to be anything that's like drastically new. Let's go. This is Tacanic Falls State Park, which is a remarkable place. It's very cool. So if you ever get the chance, now we're in Google Earth. This is the vertical exaggeration here is cranked up pretty good. So if you're in a helicopter, it doesn't really look like this, but it still is. It's remarkable if you go there. And if you go to this road, which doesn't really look like that, don't panic. You can check this waterfall out. It's beautiful. It's the tallest waterfall east of the Mississippi. It's taller than Niagara Falls. Nowhere near the volume, but really big, really nice. And you got trails to go to the bottom or the car park that is up top where you can see from the top. Okay, so water as it's sped through there has, yes, eroded away that whole valley. The short story is that the rock down here is softer than the rock up here, so this erodes away easily, whereas that resists a little bit, which keeps that shelf alive, gives you a big drop off. But yeah, that's all erosion stuff, right? Which we've kind of covered if you've made it this far, if you've done all your previous lessons, which you should have. But now, holy cow, what happened there? Did I get sucked right through the planet? That was weird. Now, let's approach from space and think about deposition. This might be a different valley, but it's all right. It's the same concept. All of the stuff that's eroded, all of that stuff, all of that earth has to be dropped off somewhere. Sediment is the word I really should be using, right? All that sediment is going to be dropped off. Now, when the river's flowing through this valley, it's higher energy. It's going faster in a narrow, constricted valley on a steep hill. But when it gets out here into the Finger Lakes, it gets dropped off. Excuse me. It gets dropped off, and you build these big piles of sediments called deltas, which you might be familiar with some famous deltas if you've been paying attention to global studies. And they're all over the place in the Finger Lakes and these at the ends of these valleys. All right, here's the one that I was at, Tacanic Falls. All right, take all of that stuff and now drop it off there. You can see it here. Erosion, 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 deposition. Erosion, 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 deposition. And that's a delta. Okay. Our local river, and I think that one video showed the difference between the, I've never heard them described as innies and outies, but it kind of accomplished the goal. And we've got some other things we've got to learn that happen along the lakeshore here that alter what goes on. But basically up here in town in Pulaski, it's narrower and it's going faster. You guys know the rapids that are in town. And as it flattens out and gets wider here, this is more of a depositional environment, which is why sand builds up, which is why you see all these like marshy islands, reeds fill it in, because this is a lower energy environment. So it's like the same golden rule. Water speeds up, erosion. Water slows down, deposition. And again, that video pointed out that these things are important historically. Let's just go to, I should have gone to Louisiana first, but Nile Delta. And the reason why they're so fertile is because life migrates towards these rivers. And as things eat and poop and fertilize, or as things live and die and break down, that creates, that's nutrients. It's like the cycle of nutrients that doesn't happen out here in the desert without the water. And all of that flows down and then eventually gets deposited. And this allowed civilization to flourish, this area over here. Not just there, but over in present-day Iraq, too, between these rivers. Okay, delta, 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 depositional environments. And the Mississippi is one as well. They call this a bird's foot delta. It's not like traditionally triangle shaped. The Greek letter delta is a triangle. That's where this comes from. This one, with a very fine sediment load, does kind of this crazy different pattern that you see down in Louisiana, New Orleans. So yeah, that's that. Notes wise, I don't really love what I had in here, so let's not beat it to death. I don't know. Um, like this part's important as we get closer to rocks because we're really opening the door to rocks here. If you take any kind of your three rock types, and I know we haven't covered them yet, don't worry about it. Take any type of rock and you weather and erode it, weather and erode it, weather and erode it, whichever kind it was, you turn it into sediments. That we should have done now. That's what we're working on, right? Weathering and erosion produces sediments. Those sediments eventually are going to get deposited, dropped off somewhere, and if they get buried, they'll turn into rock that's made from sediments. We call it sedimentary rock. That's like the long story, which we'll cover here, I think, but I don't think we'll need to do it today. Um, so one thing I'd like to bring up though is like with these deltas. So if in a map view, let's think about maybe a Nile situation where if we've got the river, do your best to draw this. That opens out into a larger body like an ocean. All right, so this would be land with an L. This would be ocean with an O. We're looking down from the top in map view with the river flowing out that way. So through the years, as deposition continues and continues and continues, let's go a little bigger. What's going to happen is that since water, it doesn't like just hit a wall and stop, it slows down incrementally. And if you remember that reference table that I know I've got hiding around here somewhere, this is way too small to see, but you can look at it in the real reference table, that as water slows down incrementally, it's going to drop off your larger particles first. And then as it goes and continues to slow down and spread out into the ocean, it will drop, say, medium particles. And then again, as it continues to go out, it'll get progressively smaller and smaller and smaller, down to like tiny ones that go way, way, way out into the ocean. Right? So nature, running water and wind, is a fantastic sorter of sediments. It does a really good job of organizing them. These deltas, and this is going to be an important concept, these deltas or any river deposits or any beach deposit or anything like that sorts and organizes particles as it flows. We have to learn about glaciers as well, and glaciers do the opposite. Glaciers just make a big mishmash out of all the different particle sizes, dump it all at once, and get out of town. That looks much different. It seems like a subtle, weird difference to bring up, but as we get closer and closer, you'll see how it works. What if we looked at this from the side? Like, what if I cut into the earth and looked at this? And again, essentially, this is your like delta deposit, right? Roughly triangle shaped, classic delta deposit, where larger things go first, then medium, then small, right? If we looked at it from side view, like what if my eye was over here and I was looking at it that way, and I hit a magic eye, I could cut into the earth. You'd have the earth, and it drops down into an ocean. So, ocean, land again. And if we've got a river flowing across the surface, like this, hint, hint, this question's going to be in the lab, like exactly. So, I'm drawing something that's going to help you in a minute, I promise. In a few minutes. It's the same exact concept. We're just kind of like saying that, okay, you get your larger particles here, and then you get your medium particles here, and then you get your smaller particles out here, down to like the really tiny ones that go way, way, way offshore. Okay, these two are the same drawing, just from different perspectives. One from the top, one from the side. Sorted, sorted, sorted. And I think maybe that's the only thing that I'll officially write in the notes. Yeah, and abrasion tends to make them rounded. I think that might be in there. That might be in that little quiz you just did. Abrasion makes them rounded off. This is the key thing. Sorted. Deposits associated with running water or wind tend to be sorted. If you've been to the beach, all you see is sand. Where are the cobbles and pebbles and boulders? Where's the silt and the clay? They're all somewhere else because nature is a very good sorter. Okay, and it's really this relationship I explained. As the water slows down, the bigger ones get dropped off first, and they go down, down, down. So the lab you're going to do, works with that. I have a tube of water. I'm going to be dropping beads into them of different sizes and thinking about how quickly do they settle, which ones settle faster. And then if I were to think about that, if you were to take those results and think about it in your head, is what if we were in moving water, the ones that sink faster, are they going to go further downriver, or are the ones that are smaller going to go further downriver? Okay, that's that. Let's call that good. We can think about that stuff later. Have that little section, move on to the lab, and we'll keep this thing moving. Thanks, folks. Keep it up. You're doing great. So long for now.